Hello everyone. Previous lecture we have studied the concept related with the chapter straight line, and in that we see locus. We see definition of locus and we see how to find equation for the locus. Then in next lecture we find or we see here old coordinates, how to find the old coordinates and new coordinates. Okay, so in today's lecture we go with the concept related with the part here straight line. Here remember, a line is the simplest locus in a plane. Line is the simplest locus in a plane. Okay, so we have to define this line. Firstly, we go with our first definition and is for intercept. Okay, we have to define the intercepts. Okay, that is x-intercept and y-intercepts. Okay, and to define the intercepts, we consider one figure, that is we consider the coordinate axis. Okay, here we consider the coordinate axis. This is our x-axis, then this is our y-axis. Here origin is at O. Let us consider one line passing through the points A and B. Suppose this is our line L1. This is our line L1, okay? And this line L1 pass through the point A. Suppose here is our A having coordinates A 0, and on y-axis we consider point B having coordinates here 0, B. Now here this small a is called x-intercept. Here I write, here small a is called x-intercept, since our point A lies on x-axis and here A is on x-axis, so A is called x-intercept. Okay, similarly here on the y-axis our point A is a B, and here this small b is called the y-intercept. Okay, so here B is called y-intercept. So remember this point here, this point is very important. Here A is called x-intercept and small b is called y-intercept. Okay, now here remember one part, a line parallel to x-axis. A line parallel to x-axis here has no x-intercept. And a line parallel to y-axis has no y-intercept. Remember this part. Okay, now we go with our next definition in this chapter, and is your inclination of a line, inclination of given line. Okay, so here I write inclination of a line. Okay, again to define the inclination, we consider our coordinate axis, we consider our line. Here acute angle made by a line with positive direction of x-axis. I repeat again, the smallest angle made by a line with positive direction of x-axis measured in anti-clockwise sense is called inclination of given line. Again, to define this part, we consider one figure. Let us consider the coordinate axis like this. This is our x-axis, then here is our y-axis. Here origin is at O. Then we consider one line. Okay, suppose this is our line L1. Okay, here we have to consider the acute angle made by a line with the x-axis. Okay, so here theta. Here we have a theta. This theta is called inclination of given line. Okay, here small theta. Here theta is called inclination of a line. And here remember one part, here theta always lies in between 0 and 180 degree. Okay, so here 0 degree is less than equal to theta is less than 180 degree. Remember this part. Okay, so we define the inclination of line. Here remember some important notes. If two lines are parallel, if and only if they have same inclination is our first note. Then in second, the inclination of x-axis and the line parallel to x-axis is always 0 degree. And in last, the inclination of y-axis and line parallel to y-axis is always of 90 degree. Okay, so here we define the inclination of given line. Now we go with our next important definition, and in that we find the slope of given line. Slope of line. Again, to define the slope of given line, we consider the inclination of given line. Let here inclination of line is theta. Okay, here I write if inclination is theta, then here tan theta is called the slope of the given line. This tan theta is called slope of given line. Here slope is denoted by using a small m. Here small m is for slope, and here m is equal to tan theta is the slope, is for the slope. Okay, so remember this part. If angle is given, if one angle is given, that is inclination is given, then we find slope of given line by using this formula. Okay, let us see one example. For this example, find the slope of line, whose inclination is pi by 4. Here one line is given, this line inclined having measure here pi by 4, we have to find slope by using this formula. Okay, here given inclination is theta is equal to pi by 4. We know to find slope we use m is equal to tan theta. Consider m is equal to tan theta. Okay, this is equal to here tan of, we know theta is pi by 4. Okay, and we know tan pi by 4 is always 1. So here slope of given line is 1. Therefore slope of given line is 1. Here is 1. Now we go with our second example. Here again we have to find slope. Okay, find the slope of line whose inclination is here given 30 degree. Inclination is 30 degree. Okay, again we have to find slope. Let us consider given things. Given inclination is here theta is equal to 30 degree. To find slope, we use m is equal to tan theta. So we consider m is equal to tan theta. This is equal to here tan of 30 degree. And we know here tan of 30 degree is 1 upon root 3. Here is 1 upon root 3. So slope of given line is slope of given line is 1 upon root 3. Okay, so very simple example. Directly by using the formula m is equal to tan theta, we find slope of given line. Okay, now we go with our next part. In that we consider 2 points. If in the line 2 points are given, then how to find slope of given line? Okay, so here I write if a of or a is equivalent to x1 y1 and b is equivalent to here x2 y2, okay, are 2 points on line L, okay. If these 2 points are given and here we have to find slope of given line, and to find the slope we consider directly form. Here remember, to find slope m we consider y2 minus y1 this divided by x2 minus x1. Remember this part. If here 2 points are given, then to find slope we use this formula, that is y2 minus y1 upon x2 minus x1. Let us see some examples to find the slope of line. Here in the example given, find the slope of line which passes through the points here in first given a of 2 minus 1 and b of 4 3 is given. Here our line pass through these 2 points a and b. We have to find slope of given line. Okay, let us consider given things again. Here given, let us consider here a is equivalent to x1 y1 and is equivalent to here 2 minus 1. That is, we know x1 is 2, y1 is minus 1. Then here for b, here b is equivalent to x2 y2 and is equivalent to 4 3. That is, x2 is 4, y2 is 3. So using these points we find slope, and by using this formula. Okay, so here consider m is equal to y2 minus y1 upon x2 minus x1. We know here y2 is 3, so 3 minus y1 is minus 1, and this divided by here x2 is 4 minus x1 is 2. This is equal to, here we know minus of minus is a plus, and 3 plus 1 is 4. This divided by here 4 minus 2 is 2, and this is equal to 2. So here slope is 2. Slope of given line is 2. Therefore slope of line is 2. Okay, so very simple example it is. Okay, directly by using the same formula we find slope. Let us consider another example. Here we consider another points. Let's see is the next one. C is having minus 2 3 and here D is having 5 7. D is having here 5 7. Again, our line passing through these 2 points C and D. Let's define these two first. Okay, here C is the first one and is here x1 y1 and is equivalent to here -2 3. Next is D is equivalent to here x2 y2. Okay, then here is 5 7. Okay, again we consider m is equal to y2 minus y1, this divided by x2 minus x1. Okay, here y2 is 7, so 7 minus y1 is 3, this divided by x2 is 5, so 5 minus x1 is -2, here is -2. Now here we know 7 minus 3 is 4, this divided by, we know minus of minus is plus and 5 plus 2 is here 7. Therefore slope of line is here 4 by 7. Here is 4 by 7. Okay, so very simple example it is. Directly by using the formula here m is equal to y2 minus y1 upon x2 minus x1, we find slope. Okay, now we see another example. Let's go with next example. Example given find the value of k, find the value of k for which points p of k minus 1, q of 2, 1, r of 4, 5 are collinear. Okay, here we have to find value of given k, and here k is given for the point P. Also given here points P, Q and R are collinear. Okay, if these three are collinear, here we know slope of PQ is equal to the slope of QR. Remember this part. If PQR are collinear, then slope of PQ is equal to slope of QR. Okay, so here I write directly given points P, Q and R are collinear. If these three are collinear, here I directly write this as, therefore slope of PQ is equal to slope of QR. Okay, now we know how to find slope of given PQ and slope of QR. Okay, so here we know our formula y2 minus y1 upon x2 minus x1. Let us consider for here coordinates of point P as x1 y1 and coordinates of point Q as x2 y2. Okay, so here to define the slope we consider y2 minus y1 in numerator. Here y2 is 1, then minus y1 is -1, this divided by, then x2 minus x1 means 2 minus k, here in denominator 2 minus k, this is equal to. Now for QR, let us consider coordinates of point Q as x1 y1 and coordinates of point R as x2 y2, so this is equal to, here y2 minus y1 means 5 minus 1, this divided by x2 minus x1 means 4 minus 2, here 4 minus 2. Therefore, I write this as, here we know minus of minus is a plus and 1 plus 1 is 2. So 2 upon 2 minus k. This is equal to, we know 5 minus 1 is 4. This divided by, here 4 minus 2 is 2. Okay, therefore, here I write this as 2 upon 2 minus k. Okay, is equal to 4 upon 2. Here 4 upon 2 is 2 only. Then I write this as 2 is equal to 2 into bracket 2 minus k. Therefore, here 2 is equal to, let's multiply this bracket by 2. If we multiply, we get 4 minus 2k. 4 minus 2k. Therefore, here I write 2k separately as here 4 minus 2. And in last, here 2k is equal to 2. That is, here value of k is 1. Here value of k is 1. So, we find value of k, okay, by using the formula. Here y2 minus y1 upon x2 minus x1. So, here we see some important examples related with the part slope of line. Here remember one part, or we consider some nodes. Here we have two nodes. Node. Okay. In first node, okay, if two lines are parallel, or we say two lines are parallel if and only if they have same slope. Remember, if two lines are parallel, then their slopes are equal. Okay, so two lines are parallel. If and only if their slopes are, they have same slopes. Remember this part. Okay, and second node, we consider perpendicular lines now. Okay, two lines having slope. Let us consider slope of first line is m1, slope of second line is m2. Okay, two lines are perpendicular. To each other if and only if product of their slopes, that is m1 into m2, is always minus 1. Or here, if m1 into product in between m1 and m2 is minus 1, then we say here given two lines are perpendicular to each other. So remember these two nodes also. So in today's lecture, we go with the concept straight line. Firstly, we define intercept, then we define inclination of line, and in last we consider slope of lines. And we see some important examples related with these definitions. Thank you.